Sorry I can't be with you today, but I want to carry on with the work so you don't feel like you're getting behind at all, and you've done so well so far. I'm sure you're going to be absolutely fine. Today what we're going to do is we're going to move on a little bit with the work you've been doing with bounds. So last lesson we worked out the upper and lower bound, and then this lesson we're going to start thinking about calculations with bounds. Now actually this gets brought up on exam papers all the time, and a lot of the questions end up becoming like 3, 4, 5 mark questions. And some of them get quite tough. So we're going to build it up slowly, and we'll pick it up again when I see you when I'm back in on Tuesday. Before I say anything more, please don't forget you have homework for Tuesday. Make sure it's submitted on Dr. Frost, and make sure your workings are uploaded and very, very clear. Okay, I don't want any shoddy working. So first things first, if we remember back to last lesson, we were talking about finding the upper and lower bound, and we said that all we needed to do, if it was A is 30 to one significant figure as it is here, then if I draw a line here with 30 in the middle, then the one significant figure is in the tens column. So that's why it's been rounded to the nearest 10. So the 10 above it is 40, the 10 below it is 20, and that left us with a lower bound of 25 and an upper bound of 35. Okay, I'm hoping that's fairly straightforward. So we can say upper bound of 35 for A and a lower bound of 25. If we look at B says 5.2 to one decimal place. So there's the 5.2 to one decimal place. The number above it is 5.3. The number below it is 5.1. Go halfway in between to find the upper and lower bound. So the lower bound would be 5.15 and the upper bound would be 5.25. Okay. So whenever you see a bounds question, whenever it tells you that you've got a number that has been rounded, okay, the first thing you should do is find the upper and lower bounds of those numbers. Don't do any calculations, just find the upper and lower bounds, draw a table like I have here. So that's step one in every question. Then it might say find the upper and lower bound of a calculation. And here we've got A plus B, we've got A minus B, A times B, and A divided. That's divided at the bottom. Now, that doesn't mean do an A plus B 30 plus 5.2 and then find the upper and lower bound. It means find the upper and lower bound of A, the upper and lower bound of B, and now try and work out which combination is going to get us the best result. So, if I look at A plus B, it says, what's the upper bound of A plus B here, okay? So I'm looking at this one here. What's the upper bound of A plus B? And I need to go back up here in my table and think, actually, what's going to produce the biggest possible result of A plus B? And I'm hoping would be quite clear that that's 35 plus 5.25. Plus 5.25. And that's the two upper bounds there. And likewise with the lower bounds, what would give us the smallest answer if we did a calculation with addition? Well, that's 5.15. I'm going to jump a row now because I think it's probably easier to understand addition and multiplication together and then to understand subtraction and division. So multiplication very much follows the same rule as addition. If it says find the upper bound of A times B, then I'm thinking, well, I'm going to use the biggest possible number and I'm going to times it by the biggest possible number. And if it wanted to find the lower bound of A times B, I'm thinking, well, I'm going to use the smallest possible number of A and times it by the smallest possible number of B. And whatever the answer's there, I'd then put it into my calculator and I'd work out the answers. Okay? However, with subtraction and division, it's slightly different. With subtraction, if I want to find the upper bound, then what I need to do is go, right, I'm going to start with as much as possible. Sorry, don't know where that's come from. I'm going to start with as much as possible. But in order for my answer to be as big as possible, I'm going to take away the smallest amount possible. I'll repeat that again. In order to get the biggest answer out of A take away B, I'm going to start with my biggest possible value of A and take away as little as I can of B. And likewise with the lower bound, I'm going to start with as little as I can and take away the maximum possible amount to get the smallest possible number. And that rule follows with division as well. If I start with the biggest possible number and share it among as few people as possible, I'll get the upper bound. Whereas if I start with the smallest possible number and share it among the smallest amount possible, the largest amount possible, then I'm going to get the lower bound. And we can generalize these. So let's generalize this a bit so you've got something to work with. If I'm looking for, I'm going to do it slightly differently. I'm going to go lower bound here and I'm going to go upper bound. Okay. And we're going to go through these. So if I'm doing A plus B, then for the lower bound of addition, I would do lower bound plus lower bound. And for the upper bound of addition, I'll do upper bound plus upper bound. Similarly, if I was looking at multiplication, I would do lower bound times lower bound. Sorry, that keeps happening. To get the smallest value of the multiplication. And I'd do upper bound times upper bound to give me the largest value of the multiplication. It's only with division and subtraction that we change, but they both follow the same rule. To get the smallest value of subtraction, I start with the lower bound and I take away as much as I possibly can. To get the largest possible value, I start with the biggest possible number and I take away as little as I possibly can. Similar logic here for a division. If I start with the smallest amount possible and I share it among as many people as I can, I'll get the smallest answer. Whereas if I start with the biggest amount possible and I share it among as few people as possible, I'll get the biggest answer. So there's kind of your general little rules, okay? That's your table that's well worth getting here, okay? That is your table there, okay? So you might very simply get questions like the one on the left-hand side in this table, but it's highly unlikely, okay? Although I have given you some in the worksheet that follows. I'm going to go through two other questions that are sort of building up to more exam questions, and it looks a little bit like this. Find the maximum and minimum perimeter of a rectangular garden, measuring 38 metres by 20 metres to the nearest metre. And the minute it says to the nearest metre, I'm going, right, that means I need to have 38 and 20, and I need to find the lower bound and the upper bound for each of them. So when I do 38, we draw our number line. It says to the nearest metre, so the metre above it is 39. The metre below it is 37, so we can see 37.5 and 38.5 are our values. When it goes to 20, be careful, it says to the nearest metre, not to one significant figure, so 21 is above, 19 is below, and likewise again, we can say 19.5 is the smallest, and 20.5 is the largest. Let me just do that, there we go, 20.5. Now it says, which bound of each number do you need to use to find the overall maximum perimeter? So the overall maximum perimeter, if it's a rectangular garden, so if we do upper bound of perimeter, so upper bound of P, is going to be equal to 2 lots of the upper bound of the width plus 2 lots of the upper bound of the length. I hope that makes sense. If I use the biggest possible numbers in this sense, I'm going to get the biggest perimeter. So if I write this a bit more clearly, the perimeter upper bound, I generally write it like that, is given by 2 times, well, the upper bound of 1 is 38.5, plus 2 times the upper bound of the other, which is 20.5, and some quick maths in my head as I've left my calculator in my bag, tells me that it's 41 plus 77, which I think is 118 metres. Forgive me if that's not right. Okay, so there's your region. So 118 metres. And likewise, if I want to find the lower bound, so the minimum possible perimeter, so the lower bound of P, I'm going to do 2 lots, because don't forget it's a rectangle, okay? So I need 2 lots of the lower bound of the width, and I need to add on 2 lots of the lower bound of the length. So in this case, the perimeter lower bound is equal to 2 times 37.5 plus 2 times 19.5, which is 39 plus 75, which is 114. and check our units, meters. Okay, so there's a nice easy one. It's addition, and generally addition and multiplication are the easy ones, because if you're looking for the upper bound, you use the upper bound numbers. If you're looking for the lower bound, you use the lower bound numbers.